here's part 1 of your review. So the directions are important on this first part because it's telling you how to solve it specifically. It says use the reciprocal or quotient identities to find each value. All right, so I've got cotangent and cosecant. So I know that cosecant is 1 over sine. So the sine of x is equal to 1 over negative 5 times the square root of 2. So I can rationalize that now or I can rationalize it later. I think I'm just going to wait. So cotangent is cosine over sine. So the cotangent is negative 7. That's equal to the, again, cosine over sine. So the cosine of x is what I'm looking for. The sine of x is 1 over negative 5 square root of 2. So although I'm dividing by a fraction, I'm not going to multiply by the reciprocal here because that's what I would do to clean this up. I want to get cosine of x by itself. So I'm going to multiply both sides by the denominator, which is this right here. So it's going to give me negative 7 times 1 over negative 5 square root of 2. That's equal to the cosine of x, which means that cosine x is equal to a positive 7 over 5 square root of 2. Rationalize, and that gives me 7 square root of 2 over 10. So the cosine of x is 7 square root of 2 over 10, and it is positive. Okay. So I want the tangent of theta if secant is negative 9/5 and the sine is 2 square root of 14 over 9. So tangent is sine over cosine. Secant is the reciprocal of cosine, so the cosine of theta is negative 5/9. So tangent, which is what I'm looking for, is sine over cosine. So the sine is 2 square root of 14 over 9 divided by cosine, which is negative 5/9. So this one I do want to simplify my fractions. So these two I'm going to multiply by the reciprocal. So I get 2 square root of 14 over 9 times a negative 9/5. These 9's cancel out. And tangent theta is equal to 2 square root of 14 over 5, and it is negative. All right, number 3, directions are important here as well. It says, use Pythagorean identities to find each value, each exact value. So I have the secant, and I want the cotangent. Well, I'm going to have to use the secant here, or I could make that into cosine, but that's not going to help me. So secant, I have an identity that says tangent squared alpha plus 1 equals secant squared. So I'm going to go with that. So tangent squared alpha plus 1 equals secant, which is negative 5 square root of 6 over 12 squared. All right, so tangent squared alpha plus 1 equals, so that negative 5 square root of 6 squared, when I square the square root of 6, that's 6, square 5, that's 25, so it's going to give me a negative 150 over 144, and then I'm going to reduce that fraction. It's not negative, it's positive because I squared it. Then I'm going to reduce that fraction, and it gives me 25 over 24. I need to subtract 1 from both sides, which is the same as subtracting 24 24ths, so that leaves me with 1 24th left. So tangent of alpha is equal to plus or minus the square root of 1 over 24, which is plus or minus 1 over 2 square root of 6. Then when I rationalize this, well, I don't want to I can rationalize it, but I don't need to because I'm looking for the cotangent. So it's fine that the square root's in the denominator because I'm about to take the reciprocal. And then I got to figure out this whole plus or minus thing here. I don't know which one it is supposed to be. That's why I have this up here. And I had told y'all we're going to change that to sine because it was a mistake. So secant, which is the reciprocal of cosine, is negative and sine is positive. So if sine is positive and cosine is negative, you have to be in quadrant 2, which means that cotangent is negative, and should make that as so cotangent is negative, so this is going to be cotangent of alpha is equal to negative 2 square root of 6. All right, so then we have tangent of a equals 4, secant of a is less than 0. We want to find sine. So using the Pythagorean identities, tangent is going to give me secant, because you got tangent squared plus 1 equals secant squared, like we just used right here. So we're going to get 4 squared plus 1 equals secant squared a. Okay, so this is going to be 17, take the square root. So secant of a is equal to plus or minus the square root of 17. All right, so then I got to figure out if it is plus or minus, and what I really want, since I want to find sine, I'm going to make this into cosine, because nobody asked me for this, but I need it. So tangent is positive, and cosine is negative, so this right here tells me it's supposed to be negative. So the cosine of a is equal to negative 1 over the square root of 17, which is negative square root of 17 over 17. Just go ahead and make it like that. And so that means if tangent is positive and cosine is negative, I'm in quadrant 3, which means your sine is also going to be negative. And now that I have this, I can go and do the Pythagorean identity with sine. So sine squared a plus negative square root of 17 over 17 squared equals 1. So sine squared a equals, not equals, sine squared a plus, when I square this, it's going to give me a positive 17 over 289 equals 1. So I need to subtract this fraction from both sides, which means this 1 is really like 289 over 289. So I get that sine squared a is equal to 272 over 289. And I know that I want it to be negative, so sine of a is equal to negative square root of 272 over 289. Well, the square root of 289 is 17. And then when I rationalize this, I'm going to get 4 times the square root of 17. So sine of a is equal to negative 4 square root of 17 over 17. All right, next page. I'm going to simplify each trigonometric expression, which means you got to keep your equal signs going. Make sure at each step it's actually equal and you don't just have pieces everywhere. When I'm looking at these, I got 2 terms here, and I have a GCF, so I'm going to factor out my cosecant squared. That leaves me with cosine squared a minus 1. And then I can change that cosine squared a minus 1. That does not give me sine squared a, because if it's cosine squared minus 1, that's actually going to give me negative sine squared a. Cosecant is 1 over sine squared times negative sine squared a. Put that over 1. Those cancel out, and your answer is negative 1. All right, so looking at number 6. In the numerator, I have a difference of squares. That's pretty easy to put together there. So cosecant squared theta minus cotangent squared theta all over sine theta. So I'm going to combine those two things in the numerator. So first I need to make them into the quotients and reciprocals. So this is all over sine theta. So cosecant squared is going to be 1 over sine squared theta minus, and then cotangent is cosine squared theta over sine squared theta. All right, well in the numerator, I already have a common denominator. So this is going to give me 1 minus cosine squared theta over sine squared theta all over sine theta. So 1 minus cosine squared is sine squared. So this gives me sine squared theta over sine squared theta all over sine theta, which gives me 1 over sine theta, which is cosecant theta. All right, number 7. So I'm going to need to substitute some stuff in here. I know in the denominator I only have one option for the sine of 2x. That's going to be 2 sine x cosine x. But then in the numerator I have 1 plus. Then that cosine of 2x, I have a couple of options. Or 3 options actually. The one that has cosine and sine in it, I don't think that I want to use that one just because I don't want to introduce cosine and sine if I don't have to. So then I have either 1 minus 2 sine squared theta in there, or 2 cosine squared theta minus 1. So if I put that in there with the minus 1, it's going to cancel that 1 out, and that might be kind of nice. So we'll go with that one. But again, it doesn't really matter because you'll eventually get there. But I'm going to change this to 2 cosine squared theta, or x, I'm sorry, minus 1. So now this 1 minus 1, those cancel out. So this gives me 2 cosine squared x over 2 sine x cosine x. The 2's cancel out. This cosine cancels out with one of those. So I end up with just cosine x over sine x. And that gives me cotangent x in the end. Alrighty, number 8. Got a lot of substituting to do with these a plus b and a minus b going on here. So the cosine of a plus b, that's going to give me cosine a times cosine b minus sine a times sine b. Plus, and then the cosine of a minus b gives me cosine a cosine b plus sine a sine b. All over. Then in the denominator, the sine of a minus b gives me sine a cosine b minus cosine a sine b minus, and so since I'm subtracting something with more than one term, I need parentheses. This is going to be sine a cosine b plus cosine a sine b. All right, so now it's all substituted in, and I just need to clean it up a little bit. So in the numerator, I have cosine of a cosine b, and there's another one of those right here. So these two together give me 2 cosine a cosine b. Then I have this negative sine a sine b and a positive one, so those two just cancel each other out. So that's all I'm left with in the numerator. Then I have sine a cosine b, then minus sine a cosine b, so those two cancel each other out. I have this negative cosine a sine b and a positive one, but they don't cancel each other out because I have to distribute this negative. So it's really negative cosine a sine b minus the same thing, so you get negative 2 cosine a sine b. So then the 2's will cancel out. The cosine a's cancel out. I still have this negative sign, so it's negative cosine b over sine b, which means in the end I end up with negative cotangent b. And I'm done. So there's your simplifying. Proving is actually a little bit nicer because you know what your end result is. And I would say on number 9, we're going to start with the left-hand side. It definitely looks a little bit more complicated there. So I don't like it when the denominator has more than one term, so if we can fix that, that would be great. So we have a Pythagorean identity that is tangent squared plus 1 equals secant squared. So if I do 1 minus secant squared, that's going to end up being a negative tangent squared. So this is sine of x over negative tangent squared x equals negative cotangent x times cosine x. Remember, you have to rewrite the whole thing every single time. So now I'm going to simplify this. It's going to give me the sine of x over negative sine squared x over cosine squared x equals negative cotangent x cosine x. So then I can multiply by the reciprocal here, so I'll have sine of x over 1 times a negative cosine squared x over sine squared x equals negative cotangent x cosine x. So sine x cancels out with that, and I get negative cosine squared x over sine x equals negative cotangent x cosine x. So remember, my goal here is to make these two look the same. Well, if I split this up, and let's see, do it over here, and I make this negative cosine x times cosine x over sine x. So this, I'm splitting it up even though it's multiplication, equals negative cotangent x cosine x. So then here, this cosine x stays cosine x. This is going to become cotangent, so I end up with negative cotangent x cosine x equals negative cotangent x cosine x. And I'm done. Alrighty, number 10. So I want to start with the fraction side again. And there's nothing squared, so there's no Pythagorean anything I get to put in there. But I can make these into their reciprocals, into their quotients. So it'll be 1 over cosine y over sine y plus sine y over cosine y. And that has to equal sine y cosine y. So I'm going to get a common denominator in the denominator. So that common denominator is going to be sine y cosine y. And then in the numerator, this would end up being cosine squared y plus sine squared y. That's equal to sine y cosine y. So this numerator becomes 1. So I get 1 over sine y cosine y equals sine y cosine y. So when I multiply by the reciprocal, basically I'm going to take 1 and multiply by the reciprocal of this, which is sine y cosine y. And I'm done. Alrighty, so this next one here, I'll start by distributing my sine squared alpha. So when I do that, I'm going to end up with sine to the 4th alpha minus, well, cosecant squared is 1 over sine squared. So that means those just give me 1 in the end, over sine squared alpha plus 1. That's equal to negative cosine squared alpha. So what to do here? Well, in the numerator, I have a difference of squares, so I'm going to factor. So I get sine squared alpha plus 1 times sine squared alpha minus 1 all over sine squared alpha plus 1. That's equal to negative cosine squared alpha. So these cancel out. No canceling here, no reducing here. That would be making up a math. Big fat no. This is good because we're multiplying these things. So then that leaves me with sine squared alpha minus 1 equals negative cosine squared alpha. And sine squared minus 1 is negative cosine squared, so negative cosine squared alpha equals negative cosine squared alpha. And we are done. Okay. So on number 12, definitely going to start with the right-hand side. So I rewrite the left-hand side. Cotangent theta plus 1 equals, all right, so I'm going to have 2 over 1 minus tangent theta, and then I want to substitute in for that. So on your card here, you've got, there's no cotangent of 2 theta, but there is a tangent of 2 theta, so you just use the reciprocal of that, which would give me 1 minus tangent squared theta over 2 tangent theta. So then I combine all that, and I'm going to get cotangent theta plus 1 equals 2 times this, and now this right here is a difference of squares, so I'm going to go ahead and make that 1 plus tangent theta times 1 minus tangent theta all over 1 minus tangent theta times 2 tangent theta. So these 2's cancel out right here. This cancels out with this. So I'm going to rewrite what I have. I have cotangent of theta plus 1 equals 1 plus tangent theta over tangent theta. So now I'm going to split my fraction and get cotangent theta plus 1 equals 1 over tangent theta plus tangent theta over tangent theta. So cotangent theta plus 1 equals, well, the reciprocal of tangent is cotangent, plus, and then that will give me 1, and I'm done. All right, number 13. On the left here, I'm going to have 2 terms, so I'm going to factor out the secant of a. So secant a times sine squared a plus 1 equals 2 secant a minus cosine a. All right, so if I change that sine squared a, that might be helpful to me. Now, sine squared a plus 1 is not an identity that's on there, and that's not something I can manipulate that to get. So I'm just going to change this one, because distributing the secant's a reciprocal of cosine, nothing's going to happen in there. I'd rather have cosines over here. So it's going to give me secant of a times. So sine squared is 1 minus cosine squared, and then I still have this plus 1 here. That's equal to 2 secant a minus cosine a. So over here, I've got, there's a 1 and a 1, they're both positive. So now I have secant a times 2 minus cosine squared a equals 2 secant a minus cosine a. If I distribute now, so secant a times 2 is 2 secant a minus cosine squared a over, or times secant a. Secant is 1 over cosine, so it would cancel one of them out. You just get cosine a. It's equal to 2 secant a minus cosine a, and you're done. All right, 14. Going to require some substituting in here. This is like sine of a minus b. So left-hand side, negative cosine of 2x equals 2 times the sine of x times, all right, so sine of pi minus x, that's like a minus b. It's going to give me sine of pi times the cosine of x minus the cosine of pi times the sine of x, then minus 1/2 cosecant x. All right, so now I've got to clean this up a little bit. Still have this negative cosine of 2x equals 2 times the sine of x. So let's clean this up. Sine of pi is, what is that? It is 0. So 0 times cosine x just makes this term go away. Then minus cosine of pi times sine of x. So cosine of pi is negative 1. So it's minus a negative sine x, which is going to give me just a positive sine x, minus 1/2 cosecant x. Left-hand side, rewrite. Now I'm going to distribute this. So 2 times sine is 2 sine squared x. And then minus 2 times 1/2 is just 1. Sine times cosecant is just 1, because those are reciprocals. So now if you look on your formula chart there, cosine of 2x, one of the options is 1 minus this. Well, this is negative. If I factor out that negative, then this is going to give me 1 minus 2 sine squared x. And that does match the cosine of 2x. So negative cosine of 2x equals negative cosine of cosine of 2x. And we are done. All right, number 15. It says solve each equation for all solutions in the given interval. Write all answers in radians. All right, so I've got negative 8 cosine theta, so I'm just going to divide both sides by negative 8. So I end up with cosine of theta equals negative square root of 3 over 2. I am looking from negative infinity to infinity, so I want all 4 quadrants here. So theta is equal to, where is cosine negative? It's cosine inverse of square root of 3 over 2. So cosine is negative here and here. It means I'm going to have 2 answers, but really an infinite number of answers. So theta is equal to, well, cosine inverse of square root of 3 over 2 is going to be pi 6, but I want my second quadrant pi 6 answer, which is going to be 5 pi 6 plus 2 pi n. And then for the third quadrant, that would be 7 pi 6 plus 2 pi n. There are my answers. All right, number 16. I've got cosecant squared and cotangent in here, so I think I want to replace this with a cotangent so that I have all of them the same. So cotangent squared plus 1 equals cosecant squared, so this is going to become cotangent squared of beta plus 1 equals 2 cotangent beta. Then I'm going to set it equal to 0, so cotangent squared beta minus 2 cotangent beta plus 1 equals 0. So I'm going to factor. We get cotangent of beta and cotangent beta. Signs have to be the same. They both have to be negative, and these have to multiply to give me 1. So there you go. So this was really a special case, which is just cotangent of beta minus 1 squared. But I just use it once, and I get cotangent beta equals 1. So that means that tangent beta equals 1. And beta is going to equal the tangent inverse of 1. I'm going from pi to 2 pi. The only place where tangent is positive down here is the third quadrant. So my third quadrant angle for my pi fourths, because the tangent inverse of 1 is pi fourths, is going to be 5 pi fourths. All right, last page. So again, I have sine and cosine mixed, which sometimes that's what happens. But I also have this cosine of 2a, which I know that I need to replace. When you have cosine of a double angle, you have 3 options of what you could put in. I'm thinking I like the option that just has a sine in it and no cosine, since this is sine and this is sine here. So I'm going to get 4 sine squared a equals negative, and then cosine of 2a is 1 minus 2 sine squared a plus 3 sine a. So then I distribute that negative, and I'm going to get 4 sine squared a equals negative 1 plus 2 sine squared a plus 3 sine a. So I want to set it all equal to 0 and move it all to the left. So it'll give me 2 sine squared a minus 3 sine a plus 1 equals 0. So if you need to factor this by grouping, factor by grouping. But a is not 1, but it is a prime number, so now I'd have 2 sine a and sine a. The signs have to be the same. They both have to be negative. And these have to multiply to give you 1, so it's got to be 1 and 1. Check myself, that's negative 1, negative 2, that would give me my negative 3, so I'm good. So that sine of a is equal to 1/2, and sine of A is equal to 1. So A is equal to sine inverse of 1/2, and A is equal to sine inverse of 1. So I'm going here from pi halves to 3 pi halves. So it's these two quadrants. Both of these are positive, and so sine is only positive in the second quadrant there. And so the sine inverse of 1/2 is going to be a pi/6 angle. In the second quadrant, I would make it 5 pi/6. And then the sine inverse of 1 is pi halves. So in the end, my two answers are pi halves and 5 pi/6. All right, number 18. We've got -2 plus sine squared y equals 3 cosine y plus cosine squared y. So I'm thinking I would like it to all be in cosines if possible, and I can change this. So I'm going to get -2 plus, and so sine squared is going to be 1 minus cosine squared y equals 3 cosine y plus cosine squared y. And I'm going to move them all to one side of the equal sign. I'm going to move it to the right so I can keep these positive. So this is going to give me 0 equals, it'll give me 2 cosine squared y plus 3 cosine y. And then this -2 and 1 is a -1, so they become plus 1 over there. Okay, so then I need to factor. Again, factor by grouping if you need to, but you should be able to reason through something simple like this. Signs have to be the same. They both have to be positive. And that would give me 1 cosine and 2, which gives me my 3. That multiplies there. Everything looks good. So that means that cosine of y is equal to -1/2, and cosine y is equal to -1. So y is equal to the cosine inverse of -1/2, and y is equal to the cosine inverse of -1. We're going from 0 to pi, those two quadrants there. So here, y is equal to, negative cosine would be there, and cosine inverse of 1/2 is pi thirds. I need my second quadrant angle, which is 2 pi thirds. And then cosine inverse of -1 is just pi. Put those together, and I get 2 pi thirds and pi. Those are my two angles. All right, last one. So I'm going to have to do some substituting here for my a plus b and a minus b stuff. So this is going to give me 2 times, well, the sine of a plus b here would give me the sine of x times the cosine of 5 pi/6 plus cosine of x sine of 5 pi/6 plus, and then I'm here, 2 times the cosine. Oh, sorry, not 2 times the cosine. 2 times, and then cosine of a minus b would give me cosine of x, cosine of pi thirds, plus sine of x, sine of pi thirds, all is equal to the square root of 2. All right, so I've got it all substituted in. So now I got to clean it up by actually evaluating these things that I can. So the cosine of 5 pi/6 is negative square root of 3 over 2. It's going to be multiplied by the sine of x. Plus, sine of 5 pi/6 is 1/2, which would be multiplied by the cosine of x. Plus 2 times cosine of pi thirds is 1/2. Plus sine of pi thirds is square root of 3 over 2. That would be multiplied by the sine of x. That's all equal to the square root of 2. So now I distribute my 2's. When I distribute it in here, I end up with a negative square root of 3 times the sine of x plus 2 times 1/2 is 1, so it's cosine of x, plus distribute this one. That's just going to give me cosine of x, plus distribute that. I get the square root of 3 times the sine of x equals square root of 2. All right, so this is a negative and a positive of the same thing. Those cancel out. So I'm left with just 2 times the cosine of x equals the square root of 2. Cosine of x is equal to the square root of 2 over 2. That means that x equals, we're going from pi to 2 pi. Right? So the only place cosine is positive is right here. Cosine inverse of the square root of 2 over 2 is pi fourths. So my fourth quadrant pi fourths angle is 7 pi fourths, and we are done. Okay, so this is what you can expect on your test. You can also expect maybe for me to just ask you what some of the inverse values are, and even the composite ones. You know, the sine of the cosine inverse of whatever. And at the beginning I said this was the first part of the review. This is actually the whole thing. I just didn't think I'd get through it without being interrupted. Kind of a miracle.